Suppose we wanted to calculate a least squares regression line to predict earnings for a waiter at a more modest restaurant. Using the slope formula, the slope came out to be $20. The mean shift worked was 6 hours. This mean is X bar. The mean money earned in a shift was $130. This mean is Y bar. The point X bar Y bar is on every least squares regression line because of the formula calculating the Y-intercept. Let's find this point on our LSR line. If a waiter worked one more hour than the average of 6 hours, the predicted earnings would be $20 more than the average of $130. If instead we examine shifts that are shorter than 6 hours, for each hour less worked, the earnings decreased by $20. As we go from 6 hours to 5 hours and 4 and 3 hours, we see a $20 drop per one less hour, until finally we make it all the way down to 0 hours, at which the predicted earnings is $10. This is the y-intercept. We just discovered this logically. Now the y-intercept formula does the exact same thing. It begins at the mean y, $130, and takes away $20 for each average hour worked, causing the $130 to take 6 jumps downward until it is back at $10 for no hours worked. Hopefully this explanation makes sense as to X bar Y bar being a point on every least squares regression line. If not, you could view the explanation again, but regardless of your comprehension, commit this to your memory. X bar Y bar is on every LSR line, meaning that the mean of the X values in your data set pairs with the mean of all Y values in the data set. Here's the type of question you may be asked on an exam to see if you recall this fact. A least squares regression line is y equals negative 15 plus 4x. Determine an algebraic expression for y bar. There is a basic idea one must recall about any ordered pair in a line. It is an ordered pair solution. Put the x value into the equation and you must get back that corresponding y value. Since x bar y bar is an ordered pair on the LSR line, it must be a solution to the equation. Thus, whatever the mean x value is, it must be the value substituted for x that produces the mean y as the y value. Thus, y bar must equal negative 15 plus 4 times whatever x bar is. The algebraic expression for y bar is therefore negative 15 plus 4x bar.